Warm welcome to all of you. We will talk about ML actions. I am Shayantan and I am a research associate at ISI Kolkata. So we'll talk about continuous delivery in ML with GitHub actions. So what are GitHub actions? GitHub actions are a way to automate your software workflows. You can. This is basically it's a built-in continuous integration, continuous delivery. These kind of softwares are run on the backend on either Linux, Mac, Windows, or it's running on a Docker container. So these are very easy to share, easy to write. You can use environment variables. I will in this workshop we'll tell you how to create those environment variables and share them as secrets. They are also called GitHub secrets. Through these workflows you can generate various PDF files, various metrics, graphs, plots. So these are all your artifacts. So you can store these artifacts, like you have releases tab in your GitHub repo. You might have seen what releases are. Those are actually the versions of your software. So more versions you have, your release version will keep on changing, like 0.1, 0.2, and then you go to 1.0 and hence. So either these are hosted directly on GitHub, or you can host them on your own. Those are called self-hosted runners, where you host them on your own. And these are event driven, or they might be schedule driven. So what event driven is, for example, there is a push that was created, or there was a pull request created, or there is an issue. So those are your events, and only on those events those act as the trigger when these workflows will work. Or they might be schedule driven, like it's like at a certain point of time of the day or certain day of the week your workflow will run. So I'll talk about both of these two examples in the upcoming slides. So getting started, this is how it looks like. We'll go straight off to the demo. So what you do is, first you start off with checking what this is how actually the workflow looks like. These are all your steps these are your steps for the workflow. First you set up, and then you run this checkout. So this checkout action is a very basic template action. What this actually does is, it checks out the GitHub repo that you're running. So it's like some virtual machine is running, like for some virtual machine is using this GitHub repo. So it will clone it, and then it will get inside that master branch or some branch. So that checkout thing is basically that. So after that you head to the actions tab on your repository. So you get to see the different actions that you have already deployed, you have already created. If you have not created, then you will see a build and test your repository. So you will be able to set up your workflow there itself. So you start off with a template. You will see on the right there are many templates. So you can click on any of those templates and you can start off from there. So what actually a workflow is? We have been talking about workflow since the last few slides. So what actually is a workflow? A workflow is actually a process. So it's actually an automated process, and you can actually set it up in your repository. So for example, there are many types of workflows, like those can be organizational, which actually welcome new contributors. Those can be legal, where you need a license uniformity, and that's what these workflows will ensure, that license uniformity is maintained. And application workflows, these test cross-platform frameworks. For example, if you have an Android application, and what you do in an Android application is you build the JDK. So you build the JDK and you compile them, you compile the dependencies, and after that you get the APK, right? So instead of doing this in Android Studio, which takes a lot of time and takes a lot of RAM, so when you're working on in a version control environment where you need to push code again and again, so if you don't want to, if you want to just keep on pushing the code and just you don't want to check it, so if you want to check whether the build is working or not, so for that you can set up such kind of a workflow where it on every push it runs and creates the JDK, and then pushes the JDK like the APK into the releases tab. So that thing we can do with this. So what are these events? So whenever there is an event, then these workflows will be triggered. So as I talked about, event might be a pull request, it could be a push, or like you have made the repository public, or as I talked about the scheduling thing, it's like the cron jobs. So cron jobs are actually automated backend services. These are like you set up a specific pattern that okay, so every day of this month, at every day at 12 o'clock past 1, I'll run this job. So this is how it will work. So every day at 12 o'clock it will work like that. So these are some ways that very common ways you will come to know in the next slides. So what are these actions? So actions are individual unit of work that you can combine as steps to create a job in a workflow. So you will see that there are multiple actions that I have talked about in the first slide. That was like the checkout slide. There is this checkout action. So checkout action, what it does is it checks out the GitHub repo, like it gets inside the repo and switches into the master branch. By default you have the master branch. So there are many actions. As I was talking about, you can actually use these actions. You can publish them on the marketplace, you can publish them as repositories so that other people can use. Easy to write, easy to share property is maintained in actions. So you go to the marketplace, you can find many actions. Recently there is a tweet by Peter Juras, who is a member at GitHub. He has been putting GitHub actions tip for every day in this month. So you can go ahead and check hashtag GitHub actions tip on Twitter. You will find all the tips that he is giving. So let's get started. So in the first workflow we will create a greeter bot that greets like Hindustani Bhav. You might have heard of it. It's meme material. So in in the basic workflow I have already created a repo for you. So you can see I'll go to the github.github/workflows. Then I'll go to bhav.yml. So this is the YML file that I created earlier. So I'll show this how this works. I can like change the stuff, change the messages. So I'll explain every line here. So my workflow name is greetings, and then where I am running it on events like issues and pull requests. So what my workflow will have, it will have a job. So job is, it will have a job label called greeting. It will work on a Linux virtual machine, like it will be a GitHub hosted runner. So it's a Ubuntu latest. You always have the highest functionality when you're using Linux. And what will be the steps? So in the steps you will be first using the interaction action that's given by GitHub. So it will be needing a secrets. It will be needing your GitHub token. So if you go to the settings, you will not be able to see the settings because I am the administrator. So in my case I'll show that for settings you have to go to settings, then secrets. In secrets you will see like you can see that it's secrets.github token, right? So this secrets is an environment variable as we discussed earlier. So environment variable will be required for this case. It's like having a GCC path. Like when you're trying to run a GCC file, or you're trying to run a C or C++ file, you need to mention where your compiler is there. So you need to establish an environment variable. So even here, like you have to create a GitHub token. That's your it's your actually token that actually shows that there is some kind of authorization stamp on whatever that is being happening. So that just nobody can ऐसे ही करके they won't be able to like create their own actions. So what you do is on secrets you create new secret and then you name it as token. See, if it's a GitHub token, then you cannot name it as GitHub_token. That is your GitHub's official functionality. So you need to name it as token. So I've named it as token, and then you have to fill up a value. So for my case, what I'll do is I had already filled up a value, so I'll just update that value. I'll name it as Shayantan Das. Okay, so that's my value. This is my token ID. So token and your value is Shayantan Das. You won't be able to see it again. So yeah. So repo token is this. Your issue message. What message you are going to show when you create an issue? It's जय हिंद दोस्तों. एक नंबर फर्स्ट इशू बनारेला है तू, दैट इज. एंड फॉर पॉलिटिकल विल क्रिएट, क्या बोलते पब्लिक, अपन को टाइम दे, थोड़ा देख के बताता. ठीक. सो यू क्रिएट द इशू, you change the token, and I guess I haven't made any changes, so let's make a change. One second. Yeah, so there's a change. I already created this for you, so you can like just plug in and play. So you will be able to see. I'll create a new issue. I'll create this issue name is test my bhav. I have to test this bhav. So let's see. I'll see the actions. In the actions I'll get to see test my bhav, and then I'll see this is issue number 3. So you can see issue number 3 is written there. That proves that ki issue has been created, and then only this action was triggered. So your trigger will be shown there. So let's check the issue. Okay, let's check the issue. Let's see if our action has been completed or not. No, it's still running. So yeah, once it will be completed, then we'll be able to see. Yeah, so if you can see the green tick, then yeah, all the steps in that action has run properly. So we can now go ahead and see the issues. So if you can see the issues now, I guess we should see something. Should be shown here somewhere. Okay, its first interaction is only when it's the user's first contribution. No, it's not my first contribution, so we will not be able to see it. Okay, I'll just show you an example of how I worked on it before. So it's like at that time it was my first contribution. So I created Aja Bhav. So you can see the GitHub Actions bot has commented. It's like Jai Hind dosto, ek number first issue bana raha hai. Okay. So this was a very brief intro to the workflow. So you get a warm up regarding how actions should work like. So let's see what the next issue is. It's commenting on a commit. Okay, so you create a commit, and on the commit history you will be able to see you can create markdowns on that. So I'll show you how it works. Let's go to the repo again. I have all this created earlier for you. So let's go and check out release upload. Okay, so what happens here is in the workflows you'll be able to see this file called comment.yml. So I'll just open and show it to you how you can write this stuff. Okay, so you can see the terminology is more or less same in all actions. It's just some small changes will be there. So name will be your comment below. You can name anything. So when it will be happening, it will be happening whenever you push a commit. So on the push trigger, push will be the trigger for this event trigger. So the jobs are you have to run. So where do you want to run? You want to run. It's like a story. Where do you want to run? You want to run Ubuntu latest. It's like what steps do you want to run? Okay, so my first step is I want to check out. So you want to check out, you want to git clone and then cd into that folder. and then you want to see it, git checkout master or whichever branch that is. So it will do this. See, whenever you see action slash no, so these are the official GitHub template actions. If you see some other name person's action, that is like some third party person has created it. Okay. So then after that you name it as create commit command, and you can see uses Peter Evans commit command one. So Peter Evans has created this GitHub action. So we are using GitHub workflow. We are not using GitHub actions. We are using GitHub workflows, where you are using somebody else's action. So as I said, these are easy to write and easy to share. So you can like collaborate with people, and you can use other people's actions as well. So Peter Evans creates this commit command. So within this, what you want to do is you want to define the body of your message. So your message is a multi-line command with GitHub Markdown. So it's a Markdown file. It will be shown as a whenever you have a GitHub comment. All these comments that you see on GitHub actions, issues, on issues and pull requests, every comment is basically a Markdown file if you think so. Okay. So this is actually a multi-line comment. I'm going to write this as Shayantan triggered this again. Okay. So you can see created by Shayantan, so it will create a hyperlink. Yeah. So let me start the commit. I have updated this. It is just a commit. It's not a big deal. So you will see that this commit has been created. You can see every commit has a commit unique ID, and you will see on the actions tab that I have updated this. Let me go to the commit history, and you will be seeing that okay, so I have made this change, and below that I will be seeing GitHub actions. Low, you can see this. GitHub actions is committed 11 seconds ago. So you get the hang like how this GitHub actions can work. So you might be thinking like, okay, so if I'm doing a machine learning experiment, like my run has completed, my workflow is completed, now I want the reports, I want the classification table, I want the metrics, I want the plot, I want the confusion metrics, I want the graphs, charts and all stuff. So yes, you can do that. So we'll show it in the next demo. So your next demo is codespell.yml. So this is the last basic, after which we'll directly go into the machine learning stuff. So codespell is an example of how you can write spellings. Let's go to that. I've already created this. This wouldn't have finished in one session. Let's go to the branch of codespell. Okay, I've already created this for you. Okay, so codespell, this will only trigger, mind you, this will only cause a change when you have some spelling mistakes. This will not work when you don't have spelling mistakes. Okay, this will run, it will show green, but it will not work if there's no kind of spelling mistake. So as you can see, its name is codespell. You trigger it on push or a pull request, like there's some issue in the code and you can see there's a spelling mistake in the code or something. So jobs codespell is again the, as we have done it in the bhav wala thing, that we had named it as basic, or even in the last one where I had written this name again. So yeah, codespell again. It runs on Ubuntu latest. By now you have acclimatized to how the syntax actually works. So we check it out, check this out again. So now we actually want to set up the Python. So we need the Python setup. So when I'm using this means that my runner now has the Python setup. It knows what Python is, what pip is. So now you can pip install easily. So what you do for that, you run pip install codespell and flake it. Codespell and flake it are very famous Python frameworks. So these are like Python libraries, you can pip install them. So under this run body is what you want to do is you want to do some skip creations. So using this skip creations, what you can do is you don't want to check those files that are belonging to some kind of, for example, you have this git ignore in GitHub. So skip is also kind of that kind of thing, functionality. So skip flag will do this thing. Quiet level 2 means it will quietly do this. It will not write any verbose. It will not write any logs. It will quietly do. It will basically not create any outputs on the terminal. stdin std out. Okay, so let's go to the action. Let's check out what actions have it for me. See, as you can see, in I had a file.py, so I don't think there's going to be any let me name this as Nick. I'm not sure if this is going to work because this sometimes doesn't work. So code spell, I have made a commit. Now I'll be seeing an action very soon. Let's go to the action. This is running, this is on a queue. So as you can see, it's green. Okay, so it didn't find out any spelling mistake, but yeah, if you have some kind of spelling mistake, then it will be able to get triggered. So these were the set of basic actions that you needed to know, after which I guess we will go directly to the machine learning actions. So for cron job for Python ML tasks, I will take you to one of my projects. It's this project. I'll share the name in the YouTube video in the description, or either in the comments. I'll share all these repos names. So it's the design lab. Okay, so what we had created in this one is we had created a cron service. So what the project here was is you had to do a credit card approval system here. Okay, so for this credit card approval system is you need to I'll just get down to the real stuff. You'll be able to understand. So my job name is Maven. I'm not these are all just by default it's Ubuntu latest, so you don't have to show anything. So as you can see here, like this is not an event based. This is an event based when you make a push, but under that you'll be able to see workflow dispatch. So what this does is they actually creates schedulers for you. Okay, so like example here you can see cron. So what this cron means. Okay, so you might be having this question, what this cron means. Let's go to cron tab guru. Okay, cron tab guru is the perfect place where you can check what this crons means. Okay, so my cron means, it's very simply written, at 12 next at 29th 8 12 12. So this means this cron will run every day at 12 o'clock. Okay, this will run at every day 12 o'clock at the 0th minute, 12th hour of that day, every day, every month, and every day of the week. Okay, so for example, let me do this. Let me change this. Okay, let's change this and you'll understand. You want to just see the output. So let's change this, that let's do this. So right now time is 22:22, so you can change the time as 24, and you can do this every hour, every minute of that hour. Okay, so let's do this. Let's change this, and I'll explain the rest part as well after that. I'll first make the commit so that I don't miss out that time. I want to see the workflow running live. So time is changed. Yeah, timing has been changed. Okay, timing has been changed. Let me make the commit, and after that I'll just yeah. So as you can see, okay, so as you can see, what are my jobs is, first you need to check out the repo. So you'll check it out, you'll set up the Python. So yes, now what kind of Python version do you want? You can specify that with 3.6 I want to do the pip caching. So if you're not able to do the pip caching, you won't be able to install any recommend.txt files or something. So you need to do the pip caching. See, this is much easier than learning Circle CI or Jenkins CI or Travis CI, because it's a functionality that GitHub is giving, so things are very manageable. Okay, so you can see that I'm pip install -r requirements.txt that we do normally, and after that you do this here, and you can do it here as well. It's just the same. And run source. So this is a token that I'm creating here. So run source is eucalyptus token. The eucalyptus token, you can just write any, like any token, like silly token or any kind of hack token. Any you can write just any name. Okay. So we have like created run src is your step. This your workflow, one of the step of your workflow, that run src. Okay. So how do you want to run src? You want to run it using this token. So what it will do is it will get into the src folder and run the shell script. Same for the testing. For unit testing also it will do the same thing. It will get into the cd folder and do the run testing. Okay. So as you can see, what we do is first we run the source code and then we run the tests. Okay. So what generally it should be having is, when you see the output, it is like you'll see set of credit card applicant numbers, and beside that you will be seeing whether they have got the application successfully accepted or not. Like they are applying for a credit card, so you want to check, you want to like predict. So this actually we are using tree based models for that. So using that we checked if they are getting those credit card applications or not. So let's check the actions first, and then I'll show you the output. I'll show you the time as well. Right now the time is 10:26. So the timings changed. Event has been triggered 45 seconds back, 2 minutes back when we were speaking. So you can see all have been correctly done. So install Python dependencies were there, as I was telling. Yeah, so you can see that files exist. Okay, so I guess these are just errors. These are just warnings. We'll go ahead and check the drive HQ. That's where actually what is happening is we are using it in we are actually using this in an FTP server. Like what you're trying to do is we are trying to upload an application file to the FTP server. From the application file, the running is happening there, and then you upload that. You take the application file from the FTP server, then you from there you start computing the stuff, and then you will be able to see this. One second. So as I was saying that you will be able to see a data frame file that it will show all the credit card roll numbers and whether they have got the stuff or not. So I'll open this up, and you will be able to see that application ID and status. These are the application ID, and beside that you will be able to see the status. Alright, so that shows like it's working. Like some have got the stuff, some have not got. This was an edge case. They didn't get the application ID. It didn't get its application accepted. So this was the way of how you can schedule a job. You can schedule a cron service, and you will be able to do this for other cases as well. So the next will be how to fetch metrics plots from a wine quality prediction task. So the next task that I want to show you is regarding how you can gauge the quality of your wine. So for that I'll take you back to our Silly Hacks practice repository that we were showing you earlier. So earlier I had gone to the wine prediction. Yeah, okay. So what I had done here is I have wine quality CSV file. So I'll show you the data frame. So this is your acidity, density, pH value, the amount of alcohol, the quality, chlorides, residual sugar. These are all your numerical variables in your data set only. So you create a train.py and you train it. So you want to test it again and again. So here I am using an RF regressor. I am a random forest regressor and I am predicting it. So these are, I'll also plot the residuals. I'll just plot the residuals here. So this is something that you normally do in machine learning, and what I'm going to do here is let me make just a small change so that you can see whether the values are same. Like I'll just change it 40 to like 41, and let me change the test size to 0.1. Okay, let me change the test size to 0.1. Okay, and let me change the max depth to tab 3. Okay, so let's see how it has fared. I'll make the change. I'll create a new pull request, or I already had created a pull request. So as you can see, this is running because I'll also show you what workflow that I was using, because right now we are talking about machine learning here. So I'll show you the workflow as well. It's this one prediction. Yeah. Okay, so it's the wine.yml. Yeah. So it's your wine.yml. It's your secrets.github token, as you can see. So right now we are using a container. We are not using your normal workflow runner. We are using a Docker container. So you're using the DVC organization CML Py3. So it's the CML is a very famous framework that DVC organization has provided. CML allows you to have a Docker container. So inside a Docker container, you will have a GPU, you will have all the NVIDIA files will be there. So you can also do deep learning with this. So we'll create an actions runner. You'll create that name CML run. So your workflow name, your workflow stuff. Even if you create a pipe like this, you can write all the stuff below that. So pip install requirements.txt. You run the train file, and then your model metrics get outputted to a markdown file. Then your those values are your metrics.txt. So your report.mb will be basically a comment by your GitHub bot. It will start with a model metrics as your heading, and then the metrics.txt will be plotted there. After that, data visualization will be written as a subheading, below which your CML publishes a function that will paste all these images. It will paste these images into the markdown file. These are two your images. The feature importance. In your random forest, you will have this feature importance, like which feature is contributing more towards the prediction. So you'll have that feature importance like horizontal bar charts, and in the last you will see that there will be a comment that will be created by Wine. So let's check the okay, update train.py. You can see there was a commit that was created. So this was the update train.py that we created. It's 17 seconds ago this was created. So you can see we had made some changes. Earlier the change was 41 and the test size was 0.2. So now my test size is just 10% of the total, and my max depth of the tree was 2. Now it's going to be 3 in the random forest. So your model metrics, your variance has changed. Your test variance has been explained better. 30.5%. You can see the random forest feature importance. You can see alcohol commits the most importance when it comes to predicting the wine quality. As you can see, the residuals, true wine quality and the predicted wine quality. So this is a very nice visualization tool and a very nice machine learning orchestration framework, this GitHub Actions. You can run these workflows on the go. You can make small changes instead of like you made this change, then you'll get pull this changes into a local remote, then you'll run python train.py, after which you'll get those nice looking plots, and then you'll see them, and then you have to save them somewhere. So you'll run this n times, you have to save the same images n times. So instead of doing that, you can have these as commit comments. Whenever you will create a commit, those will come as comments under that, so you'll be able to see them very easily. Alright, so this was a nice way to show metrics and plots. I'll also show how we used machine learning and deep learning projects in our lab. So I'll just go to our I just get to our DL GitHub Actions. So this was I created this just a while ago. So even all of these are like my accounts only. So what we are trying to do here is we are trying to check the classification, how much classification has happened, like what is the classification accuracy, what is the number of classes that were like having better accuracy and stuff. So we'll check all that. This is a framework that was already used. So you can see in the GitHub workflows, so you can see here I have named this as demo. Both of these are my accounts. So you can see that the name is demo. You can see that we have triggered this on a push trigger. So this will run on Ubuntu latest. Then again, for deep learning projects, we need to create a container because we need NVIDIA Docker. We'll also need all the CUDA libraries for that if you want to use GPU. So I need this Docker. So after that, I've created actions checkout. I've done this CML run. Again, I'm using the same authorization token. So I'm just doing the requirements.txt so that I have all the dependencies like PyTorch and all. I'll need that. Okay. So I'll do this pip install requirements.txt. Then I'm downloading the dataset. So in our lab we work on hyperspectral imagery a lot. So hyperspectral imagery, like you have an 200 or 300 channel image, and then you have the data, and then you have ground truth for what each pixel, which class it corresponds to. So we have the ground truth file. So it's a very popular data set is Indian Pines. So you'll see the Indian Pines data set, and then you'll see the Indian Pines ground truth for that. So we are downloading that. So you can see the wget command for that. So we'll get inside this srnn folder and we'll run the indian.py file. So once I'm completed the run, it will take a lot of time. So I'm going to just show you the output because it's like there are 3 iterations, and every iteration will have 200 epochs. So 600 epochs is going to take a lot of time. So you see I'm writing the CML report here. You'll see that the CML report I'm saving. This is the file that will be created in this indian.py. So I have to cat that and put this into a comment report.md, and then send comment report.md will create some written comments on that. So I'll just go ahead and show you the whenever like you have a comment, you can see the comment here as well. So you'll see the commit ID, and you'll see that this is worked properly, and you'll see the stuff here. So cml.yml, and I have not made any changes last time. So when I was running this, so you can see the run was completed last time properly, and you can see GitHub Actions is commented properly. You can see the overall accuracy after, as I said, 3 iterations. So these are the 3 iterations. Overall accuracy, average accuracy, the kappa score. Average accuracy is the class-wise accuracy, and you can calculate the mean. So there will be the mean, and the standard deviation will be created for all the 3 metrics. The average testing time, this is in seconds. This is the testing time and training time. So these are the mean values in the confusion matrix. So Indian Pines has around 16 classes. So you will see 16 values here. So every mean value will also have the standard deviation. So 16 values here as well. So that's it from me. I guess there were a lot of ups and downs in this workshop. This always happens when you are working with GitHub workflows. You can have syntax errors. You can have some issues like, okay, this comes after that, this comes after that. So everything like this is totally a practice based. You should just keep practicing this. You'll get to know this more. Even in your hackathon, like when you're trying to like test something very uniquely that you've thought. Okay, you don't have time to again run it again and again. So you can use this DVC or CML. This is very handy. It gives you NVIDIA Docker, so you can use it again and again in your hackathon. This will be very 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 useful, very useful. And that's it from me. If you want to know more, and you can check my GitHub and you can message me there. I have attached all my contact pages there. And thank you for being with me, because there were a lot of ups and downs in this talk, because I also forget the syntax, or I get slowed down a lot. So thank you for being with me again. If you have any questions, please let me know.